that will go on this graph, even though I don't know what the graph looks like yet. If I just wanted some points, does anyone know what I could do to find points that work? Yeah, plug them in. I can make a table, X and Y, and I can pick some points for X, plug them in, get my points for Y, and graph it. So while I take attendance, I want you to try to plug these 5 points in, finish your table out, and then graph your equation. Shouldn't take you super long. So those numbers that I put on the left, you are just taking the absolute value of them and sticking that number in the Y column next to it. Numbers on the left, you're just taking the absolute value, plugging them in.
Do we have to do arrows on the end of like our line?
Mm-hmm. Always, always. Good question. What's going on here? There we go.
So now you go -2x, and then the absolute value of -2 is 2. So you go -2 to 2.
Okay. For those of you that were able to graph it, what shape, what letter did it make? Go ahead. A V. It makes a V. And the reason for that is we have the point 1, 1, because the absolute value of 1 is 1. But the absolute value of -1 is also 1. So whatever happens on the right side is going to also happen on the left. So you'll also have 2, 2, and -2, 2, and so on. So it makes a V shape. We call this function f of x equals the absolute value of x. We call that the parent function for the family of absolute value functions. It is the most basic, simple form of an absolute value function you can have. We're not doing anything besides taking the absolute value. And we'll talk about parent functions a lot. We'll always start off with like a basic, simple function, and then we'll change some things to it. We'll shift it left, right. We'll stretch it. We'll shrink it. We'll reflect it. And that's what we have to know how to be able to graph, is all the changes to it. Okay? So that is your parent function. A few things about your parent function. Like we said, it's V-shaped. So all absolute value functions are going to be V-shaped. So everything we graph today, if you look around the room, they're all V's or upside down V's. Okay? It is symmetrical. Does anyone remember what symmetry is from geometry?
Same on both sides.
Yeah, it's like same on both sides, mirror image. It's symmetrical about, what line do we think it's symmetrical about? Yeah, the y-axis. We can fold our graph essentially over this line, and it's going to match up perfectly with itself. Symmetrical. And then kind of like we talked about, if we have the point x, y on the graph, or for example, 1, 1, we're also going to have the point -1, 1, or -x, y. That's what makes it symmetrical. 1 and -1 have the same y coordinate. 2 and -2 have the same y coordinate. Okay? And then the last thing about this graph is the vertex. Does anyone know what a vertex is? Yeah, essentially where like the two sides of your graph meet, it's the point of your V, the bottom point or the top point if it's upside down. So for your parent function, your vertex is 0, 0. This is the most basic function. What we're doing today is we're going to add some stuff, right? It's going to be x plus a number, or adding a number outside the absolute value, or multiplying a number in front. That's what we're going to graph today, and we're going to see how the graphs change, depending on what numbers there are and what negative signs we have, so on. Okay? So, that's when we get into this form. The absolute value of x, that's your basic function. this is your general form for an absolute value function. You have a number out in front that you're multiplying. You have a number subtracted inside your absolute value. And you have a number added onto the outside. I know that this doesn't necessarily look like this right now, so let's make it look like this. Let's write our parent function in terms of this general form so we can kind of see what A and H and K are. So if I look up here, what number is really being multiplied right here? Go ahead.
0?
Not 0, 1. There we go. So 1 times the absolute value of x minus what number is being subtracted here?
0.
0, okay. What number is being added off to the side?
0.
0. So although our parent function doesn't really look like this, we can make it look like that pretty easily, adding some 1s and 0s in. We just write it like this because none of these actually do anything to our equation. But we use these letters, these A, H, and K values to find a new vertex because it's going to change. The functions that we graph, our vertex might not be at the origin. It might be moved around a bit. And we're going to use them to find out if we stretched or shrunk that V shape at all. So A is your number out in front. A tells you the slope of the right side of your graph. So if we look at our parent function, what was A? 1. A is 1. And if we look at the slope of the right side of our graph, we went up 1 over 1. The slope was 1. Up 1 over 1. So that number in front tells you the slope of the right-hand side. What would the slope of the left-hand side here be? -1. It's the opposite. It's the negative version. So your rate of change on the left is negative A. We just flip the sign to make that V shape. Okay. Our vertex, that original point that we kind of start with, the bottom of our V, is the ordered pair HK. So we use A to find the slope of one side, and we use HK to find a point. Once we find that point, we count our slope and we're done graphing. So you just need HK and A. So here, what was H? 0. What's K here? 0. You have to be a little bit careful, though, with H. And this will come back up when we talk about other functions, because for the most part, all general forms of functions that we talk about are going to have an A, H, and K, and they're pretty much all going to do the same thing to our graph. So this will be applied later as well. But when we look at this H, we are subtracting a number. The general form is subtracting a number. So if I had an equation like this, absolute value of x minus 3, what is H in this case? We're subtracting, so it's positive 3. Our signs matched here. We are subtracting positive 3. It's like backwards of what you see. Whatever you see here, flip the sign. So, for example, if it was absolute value of x plus 3, what's my H value here? What number are we subtracting? Negative 3. Perfect. So just watch your signs on H only. You basically flip the sign that you see in the equation. Flip it, that's your H value. And that's something that's going to stay with us all year because we'll talk more about different functions with H's and K's. Okay, so the way we graph these things, step 1, we find our vertex, we graph it. Step 2, we count the slope on the right side and draw it out. Step 3, we count the slope on the left and draw it out. That's it. Once we graph it, or just from the equation, we can talk about transformations. What's changing between our parent function and whatever we're graphing here? Are we shifting it left or right, up or down? Are we pulling it? Are we reflecting it? And so on. And still, for our transformations, we only care about HK and A values. So, if we look, our vertex for our parent function was 0, 0. Now our vertex is HK. So we went on the y-axis from 0 to h. We went left or right h units. So that h value tells us our horizontal shift. K value, for the same reason, tells us up or down. It gets a little tricky with a value. So a value right here, whatever number's in front, no matter if it's positive or negative, that's the slope on the right-hand side. When we talk about transformations, we kind of split up the number and the negative sign if there is one. So we're now not looking at just whatever's in front. We're going to look at the number in front, and then we're going to treat the negative sign separate if we need to. So if there's a negative sign, that means we reflected across the x-axis. So all of these v's around the room that are upside down, they're going to have a negative sign in front of that absolute value. So number 2, number 3, number 6 over there. They're all going to have a negative sign in front of that absolute value. Once we handle the negative, we look at whatever positive number we now have for A. If that positive number is bigger than 1, so it could be a fraction, it could be 4/3, but if it's bigger than 1, we stretch our graph, which means if this is our original graph, we are vertically stretching it. It gets a little skinnier. We stretch it, we pull the top, we pull the bottom, it gets a little skinnier. If A is a fraction, we compress our graph. We take it and we smush the top and bottom in, and it gets a little wider. Okay? So when we talk about transformations and we use words to describe how our graph is changing, we would say, okay, we moved left 2, we moved up 3, we stretched it by a factor of whatever the A value is. So we stretch or compress by a factor of A, whatever that positive A value was. The negative we handle in the reflection, the stretch or compress, we only care about the actual number of A, not the negative or positive part. This will all make sense more when we do an example. I know this is like a lot of information thrown at you. It'll make more sense when we throw some numbers in here. So let's do that. Before we get to graphing anything, I want us to look at the equation, and we're going to write out A, H, and K, because that's all we really care about. Once we have those 3 numbers, we know everything else. So in this equation, what is my A value? 1/2. Perfect. A is 1/2. It's right there in the front. What is my H value? -4, because we are subtracting -4. Our general form has subtraction. We have to make sure there's subtraction in there. So H is -4. What about K? 6. Okay. I have those values. Let's graph it by finding my vertex first. My vertex is just the ordered pair HK. So what ordered pair is my vertex? Yeah, -4, 6. We plug in H, we plug in K. We graph it. Boom. My vertex is up there. -4, 6. And if I wanted to keep graphing, I can look at the slope on the right-hand side. Which value, A, H, or K, gives me the slope on the right-hand side? A. So the slope on the right-hand side for this one is? 1/2. So I'm going to go up 1 over 1, or over 2, sorry. Up 1 over 2. And I'm only going to put that 1 point because the rest is going to fall off. So half of my graph is done. I just have to mirror image it on the left. So instead of having a positive slope of 1/2, I'm going to have a negative slope. So I'm going to go up 1 to the left 2. Connect my dots, and I'm done with my graph. Graphing it is the easier part. Kind of writing out the transformations might be the harder part. So let's talk about transformations. Did I move from my original parent function? Did I move left or right at all? I moved left how many units? 4, yeah. I moved left 4, left h units. How many units up did I move? 6. Okay. Did I reflect my graph? No, no reflection. There's no negative sign. Did I stretch or shrink, compress my graph? Yeah. Did I, which one? Stretch or shrink? Shrink. It is, A is 1/2. So that's less than 1. So I compressed or shrunk my graph by a factor of A of 1/2. That is a fancy way of saying I changed my slope from 1 to 1/2. But that's how we write it. We compressed our graph vertically or we stretched it vertically.
Do we have to write this on the test?
Yes. And on your homework tonight, you'll have to write these out.
Like the A is equal to H.
Oh, no. Not these values, but your transformations, yes. Like on your homework today, for example, it'll say list the transformations. You need to list all of these things, whatever's happening to it. Basically, on your homework, when it says list the transformations, go through these 4 bullet points, see which ones you have, and write them down. And we'll talk a little bit more about that as well. Braden.
What would you say if it was greater than 1, like instead of compress?
Stretch. Questions on transformations or actually drawing the graph? Let's do one more thing with this graph. We can talk about domain and range. I know we haven't mentioned that in a while. But domain, does that relate to my x values or my y values? X. So if I start on the far left, do I have points over here?
Yeah.
Yep, because of those arrows. What about points all the way over here?
Yeah.
So my domain is?
Infinity.
Yes, negative infinity to infinity. Or, another name?
All real.
Yes, very nice. All real numbers.
Can we
That-
put one or the other?
Yes, you can put one or the other. The domain for absolute value functions will always be this. We can plug any number into an absolute value and get a number back. There's no restrictions on it. So your domain is always all real numbers. So if I ask you for the domain on your homework, which I will, you can just fill it out. Real number, all the way down for all your absolute value functions. It doesn't change. Your range, though, does change a little bit, depending on what your graph looks like. So range is your y value. What is the smallest y value I have? 6. Is that included or excluded? Included, because there's a point and a line there. Where do my y values stop? Yeah, never. So infinity. Boom. And that's the general form for the range, too. You're going to have the y coordinate of your vertex and one of the infinities. But we're going to be careful about the range because look over here for a second. What if our graph is upside down? It's an upside down V. Where do my y coordinates start now? Negative infinity. And where do they end? 0. So it might not always be a number to infinity. It might be negative infinity to a number, depending on which way your graph is flipped. Okay? So you can't always just like put a number in and put infinity next to it. It might change. Go ahead.
Is like the vertex and like the, also like the lines and stuff always going to be included?
Always going to be what?
Like included?
Yes. Until we talk about inequalities. But right now, for equations, yes, you will always have a bracket right here. It's always included. Great question. Any other questions before we go to the next example? Okay, let's do it. We're going to do the same thing. We're going to list A, H, and K. What's A? Yeah, -2. Perfect. What's H?
1.
+1. What's K? 3. Okay. I'm going to pause there. Before we graph it, I'm going to try to talk about the transformations first. Let's see what's changing. Do we know if I'm moving left or right or neither? What do we think? H is positive, so I'm moving to the right 1 unit. And then we move up or down K units. K is 3, So are we moving up or down? Up 3. Okay. Just still going through that bullet point list. Do I have a stretch or a shrink? Stretch. Remember, I get that -2 is less than 1, and that's the rule. A has to be greater than 1. However, when we look at this third bullet point, if there's a negative sign, we get rid of it, and we move the negative sign to the fourth bullet point. So this third bullet point only cares about the actual number, not the sign in front of it. So this is a stretch by a factor of 2. I'm going to say just times 2. Okay, fourth bullet point. Is this reflected at all? Yes, it is. We have that negative sign. So reflect over x-axis. So we don't have to graph it. We can talk about the transformations first and then graph. Go ahead.
How is it a stretch because I thought if it's a stretch, A is greater than 1.
Yes, when we look at the third bullet point, we ignore the negative sign. The negative only deals with reflections, not stretches or shrinks. So when we are looking at the value of A, I know we wrote A is -2, and that's going to be our slope on the right-hand side. But when we look for stretches and shrinks, I only care about the positive version because the negative is for the fourth bullet point. Okay? Okay. Now we graph. My vertex is where? What point? 1, 3. I graph it. Boom. The slope on my right-hand side is what? -2 over 1. -2. So down 2 to the right 1. Boom. Go ahead.
When does it not reflect over the x-axis?
When does it reflect?
When does it not? Because there's like a negative.
Yeah, if this was +2, our V would be V-shaped, not upside down V.
Oh, okay.
Yeah, so that negative in front just tells us it's flipped upside down.
Okay.
How do you stretch or compress?
The stretching and shrinking is done for you when you count your slope. So you're not like manually stretching or shrinking. You just know here's my slope on the right-hand side and it's going to stretch it for me. Because we're counting 2 down instead of 1. So we're stretching more down. Okay. Any other questions on the right-hand side? On the left-hand side, what's the slope for this piece? If this one was -2, what's this one? +2. We changed the sign. So now we graph our +2 slope, connect our line, draw an arrow, and we're done. But you cannot graph these things without knowing your A, H, and K value. So my recommendation is, and it might get annoying, but to write them down next to every problem because it helps you with graphing and it helps you with your transformations. Questions on that one? Go ahead.
Do we have to put like how many dots do we have?
Great question. Vertex and 1 on each side. So 3 total is fine here. Definitely vertex and definitely 1 on each side. So at least 3. Great question, Natalie. Any other questions? Okay, let's do the next one. First step, find A, H, and K. Here, what's my A value? 2. What's H? -3. Very nice. What's K? -2. So my vertex is at?
-3, -2.
Yeah, HK. -3, -2. I graph it.
Do we have to like write down what the vertex is, or can we just put it down?
You can just put it down. Unless I specifically ask for it, you can just graph it. There's my vertex. What is the slope on the right-hand side?
2 over 1.
2 over 1. Perfect. Up 2 over 1. And on the left-hand side, I make my slope negative. So up 2, left 1. And that's it. The actual graphing part is probably fairly simple. The harder part is actually writing down the transformations and maybe the domain and range. So for this one, Let's talk about transformations. Left or right? Which way did I move? Left, how many? 3. Up or down? Down, how many? 2. That's coming from my K value. Is this one a stretch or a shrink? Stretch, what factor? Of 2. And did I reflect it at all? No. So this, Braden, is what it would kind of look like if this was a
What
positive
does
2.
the x2 mean?
Times 2. My factor is 2. I hate times 2, but my factor is 2. I'm just not writing the word factor. Let's do domain and range for this one. Domain is always,
Negative.
yeah, all real numbers. Boom. Easy peasy. Don't you have to look at it. Range is a little harder. What is the lowest y value, the smallest y value I have? -2. What's the biggest? Infinity. So -2 included to infinity is my range. Yeah, go ahead.
Is it always included?
Always included, yes, because it's always going to be your vertex point. Was that your question as well? Yeah, this one's always included.
Wait, the one before that, we wrote down reflect over x spaces.
Uh-huh.
What did we write that?
Why?
Yeah.
Because of this negative sign right here. That reflects us. That's coming from your 4th bullet point here. We reflect if there's a negative sign in front. Okay, any other questions? Let's go back up to number 2 real quick and do the domain and range because it's like that one that I talked about on the board. Domain, we don't even have to think about. What's my domain?
3 and negative.
My domain, all real numbers. Now range, what is my lowest value for y?
Negative infinity.
Negative infinity. What's my biggest value? 3. So we have to put negative infinity first, and then we put 3. We always go bottom to top, or small to big. No, we never include infinities. Parentheses always around them. Always. Oh, that should be a parenthesis, but it does look like a bracket. There you go. Thanks. Parenthesis always around infinity. Sorry. Any other questions? Okay. I want you to try to do number 4. Graph it, write the domain and range, and write the transformations. I want you to do it all. You can talk to the people around you if you need to. Yeah. So you don't have to put anything. Leave it blank. Yeah. If you don't have a transformation, like if you're not moving right or left, just don't write anything. Just say up or down if you're moving up or down. You can just skip that bullet point. That was an aggressive hand raise. Yeah. Good. Yeah, this one is really like either kind of situation, but yeah. I think most of us are finishing up, so we're gonna do this one together real quick. Okay. First thing, A, H, and K. Someone give me A. 1, H. 0, K. -6, K. Are we moving left or right? No. Are we moving up or down? Down 6. Are we stretching or shrinking? No. So if you want to make a note of that up here, if A equals 1, we are neither stretching nor shrinking. It stays the same as our parent function. So if you want to make a note of that, that's coming from bullet point 3. So if A equals 1, neither. Brooke?
Would you take points off if you did it?
No, I would not take points off. No. So we move down 6. Did we reflect at all?
No.
No. So our only transformation here is down 6. Period. Done. Okay. Vertex. What's my vertex?
0, -6.
0, -6. Perfect. Right there. Boom. Slope on the right-hand side is 1. Up 1 over 1 all the way through.
Negative.
And then -1 for the left-hand side. Perfect. Ugh. Kind of good enough. It's a little off because it keeps like auto-correcting my lines, but you get the gist. Okay. Last thing, domain. All real numbers, always. Range, what value do I start at? -6. Do I go to infinity? Yes. Perfect. Perfect. Questions on that one? Before we do the last example, I'm going to kind of set us up for the activity that we're doing today. And in that activity, you're going to have to go backwards. So I'm just having a blank paper here. Don't worry about everything else. You don't have to write this down, but I do want us to listen because it has to do with our activity. For the activity, we're going to be given a graph, and I want you to write the equation. So I'm just going to graph randomly something. Okay, here's my absolute value graph. We're going to do the same thing that we did, but we're going to do it in reverse order. What is my vertex? That's step 1.
3 and 4.
3, 4, perfect. So from my vertex, what's my H value? 3. What's my K value? 4. What's the slope, aka A, on the right-hand side? Yeah, down 2 over 1. So A, or my slope, is -2. Once you find A, H, and K, we just take them and we plug them back into that general form. So Y, or f of x, is equal to A, so -2, times the absolute value of x minus h, so -3, plus k, plus 4. So that's what you're doing today. It's a little more difficult to go backwards because you have to think about it differently. So for your activity today, and we're not doing it quite yet, but you're going to look at the graphs of these green papers. You're going to write the equation, and that equation will lead you to another graph to do. Okay? But I just wanted to, just in case we had questions on that. So that's how we go backwards. Our last thing for our actual notes today is inequalities. So just like how we had linear equations and inequalities, we also have absolute value inequalities that we can graph. When we graphed linear inequalities, these were our steps. Step 1, we graphed something called the boundary line. And if we remember, the boundary line is just this equation with an equal sign instead. We graphed the boundary line. And we had to see if our boundary line was dashed or solid. Does anyone remember what made it dashed? Go ahead.
If it was just regular and not equal to.
Yeah. If it was strictly less than or strictly greater than, then we did a dashed line. And if it was less than or equal to or greater than or equal to, it was a solid line. Same thing here. Step 1, we're going to graph the absolute value. We're going to make it dashed or solid. And then the last thing for inequalities was our shading. So for linear, I said if it's y greater than, you shade above. If it's y less than, you shade below. Same thing works here, but it's kind of a little harder to see what's above and below. So if it's y greater than absolute value of x, here's what it's going to look like. You'll have some absolute value function, like so. And if it's greater than, I am shading in the V right here. You can think of it as above this line on the left and above that line on the right. So I'm shading this piece. It's different if my A value was negative, if I have something like this. And if it's greater than, now I'm shading above this line and above this line. So it's like outside the V. So instead of like a above or below, it's really in between or outside your shape, but it changes depending on which way our shape is flipped. So it gets a little wonky.
So if y is smaller than x, the absolute value of x, it's like reversed.
Yes. For less than, if we have a non-reflected absolute value graph, we are shading below each line. So yeah, it's almost reversed. We're shading outside the V. And if it's upside down and it's less than, we shade inside. But if we cannot remember this, because it's not as easy as linear, if we can't remember it, what do we do? How do we know what to shade? We test a point, we plug it in, it will always work. Okay? So that's actually what we're going to do for our example. We're going to test a point just so we can practice plugging stuff into absolute values. But just know that these 4 things are always going to be true for your absolute value. Okay. And that's it. We graph the boundary line, we make it dashed or solid, we shade. So let's do it. For this one, what's my A value? -2. What's my H value? 3. And K? +4. So my vertex is at 3, 4. So I plot 3, 4. Boom. What's the slope on the right-hand side? -2. Is this going to be a dashed or a solid line? Dashed, because it's strictly greater than. So I'm going to count my slope on the right-hand side and then draw a dashed line. Like so. Repeat the process on the left with a positive slope. And that's my graph. The last piece is pick a test point, plug it in. I already know that I have an upside down graph. It's greater than. I'm going to be shading on the outside. But just bear with me as we plug in this point, because we have to plug in points when we check any of our absolute value equations anyways. So it's not bad practice to plug it in. So let's plug in a point, and I told you what point to pick if we can. What point? The origin, 0, 0. We can always pick that point unless our line is on it. In this case, it's not. So we plug it in. If I plug this in, I am asking, is 0, that's y, greater than -2 times 0 minus 3 plus 4. I'm kind of out of room here, but. Then we check it. Here's 0, maybe greater than. What's 0 minus 3? -3. What's the absolute value of -3? 3. So I'm just taking it a little piece by piece. And then we can kind of figure it out. What's -2 times 3? -6 plus 4. -2. Is 0 greater than -2? Yes. So I would shade on the outside, which is what I knew was going to happen anyways because of the tricks that I told you. But we would shade the outside. And that's it. So you find your A, H, and K, you graph your vertex, and you count your slope. Any questions about today? Hopefully it was a nice, hopefully easier break. Okay.